In this video, we're going to take a look at section 3.7, which is on inequalities in two variables. Now, our first objective here is to determine whether an ordered pair is a solution to an inequality in two variables. Let's take a look at an example. So, determine whether 1, negative 4 is a solution of 4x minus 5y less than 12. So, whenever you're trying to check if anything is a solution, just like what we've seen before, you're always going to plug in the values. So we have an ordered pair, so we have an x and y value. Let's plug those in and see if it gives us a true statement. So we have 4 times x. Now our x is 1. So let's replace it with 1. We have minus 5 times negative 4. And now we want to see if this is less than 12. Okay, so let's go ahead and simplify it. So 4 times 1 gives us 4. And then negative 5 times negative 4 gives us positive 20. We want to check if this is less than 12. Simplify a little bit more. So 4 plus 20, we get 24. We have less than 12. Now check to see if this is a true statement. So 24, this is not less than 12. So this is not true. So that means 1, negative 4 is not a solution. Let's take a look at another one. So this time we're going to determine if 6, negative 8 is a solution of 4x plus 3y greater than or equal to 0. So let's go ahead and plug in our ordered pair. So we have 4 times 6. We have plus 3 times negative 8. We want to check to see if this is greater than or equal to 0. So first, 4 times 6 gives us 24. Now 3 times negative 8 gives us negative 24. We want to see if this is greater than or equal to 0. Now 24 minus 24 gives us 0. We have greater than or equal to 0. So 0 is not greater than 0, but however, it is equal to it. So 0 is greater than or equal to 0. Okay, so this is a true statement. So that means that 6, negative 8 is a solution. Now, this is going to play an important role when we start graphing inequalities. So checking to see if an ordered pair is a solution or not, it's going to help us determine what side to shade in when we start graphing. Let's go ahead and take a look at our next objective. So we're going to graph inequalities in two variables. Okay. Now, the first thing that you're going to do is change the inequality symbol to an equal sign. So whatever it is the inequality is that's given to you, change it to an equal sign. Then you're going to graph the equation. Okay. My recommendation is put the equation in slope-intercept form, and then use your slope and y-intercept to graph it. Now, if you have a less than or equal to or greater than or equal to symbol, you're going to use a solid line to connect the points. Okay. So that means that those points that are on the line, they satisfy the inequality. Now, if you have less than or greater than, you're going to use a dotted line to connect the points. Okay. So if it's less than or greater than, that means that those points that are on the line, they do not satisfy the equation. Or I'm sorry, they don't satisfy the inequality. Then your third step, you're going to choose a test point that is not on the line and plug it into the original inequality to determine which side to shade it. Okay. Let's go ahead and take a look at an example. So we have the inequality 6x minus 3y is less than 18. So we want to go ahead and graph this. So our first step, change the inequality to an equal sign. So I have 6x minus 3y is equal to 18. Now let's go ahead and get this into slope-intercept form. We get negative 3y is equal to negative 6x plus 18. Next step to get y by itself, divide both sides by divide both sides by negative 3. We get y is equal to, we get 2x minus 6. And now we could go ahead and use our slope and y-intercept to graph it. So we have m is equal to 2. This is our slope. And our y-intercept is 0, negative 6. Okay. So we have 0, negative 6, which is this point over here. And now our slope, remember this is 2 over 1, it's telling us to go up 2 and to the right 1. And now we get this point. Now that we have 2 points, we could go ahead and connect them with a line. Now be careful here, since it's just less than, we don't have that equal to sign underneath. We're going to connect these points with a dotted line. And now we have to determine what side to shade in. So in order to determine what side to shade in, you're going to pick a test point. It doesn't matter which point you choose as long as it's not touching the line. Now a convenient choice, we could use this point right over here. We could use this origin. Okay. So we have a test point of, we're going to use 0, 0. And now we're going to plug it into their original inequality. So our original inequality was 6x minus 3y is less than 18. So let's go ahead and plug it in and see if it gives us a true statement or not. So we have 6 times 0 minus, and then we have 3 times 0. And we want to see if this is less than 18. So go ahead and simplify. 6 times 0 gives us 0. Negative 3 times 0 also gives us 0. So we have 0 is less than 18, which is a true statement. Now, since it's a true statement, we have to shade in the same side as the test point. So my test point was right over here. Since it gave me a true statement, I'm going to shade in the same side as the test point. And now we have the solution. We have the graph of our inequality. Any point that's in the shaded region makes our inequality a true statement. These are all the solutions to that inequality. Now the dotted line that we use to connect the points, every point that's on that dotted line would not make that inequality a true statement. So that's why we have a dotted line when we connected them. Let's go ahead and take a look at another problem. So graph the inequality, we have 4x plus 3y is greater than or equal to 12. So first step, change your inequality to an equal sign. And now let's get this into slope-intercept form. So we get 3y is equal to negative 4x plus 12. Next step, to get y by itself, go ahead, divide both sides by 3. So we have y is equal to, we have negative 4/3 x plus 4. So remember, you have to divide each one of those terms by 3. Okay, so our slope, we have negative 4/3, and our y-intercept is 0, 4. So let's go ahead and use this information to graph. So 0, 4 is this point right over here. And now our slope is telling us to go down 4, then to the right 3, which gives us this point. Now, since our original inequality we had greater than or equal to, what that means is we're going to have a solid line connecting these 2 points. So that means every point that's on that solid line makes our inequality a true statement. Okay. But now we have to determine what side to shade in. So let's go ahead and pick a test point. Remember, you could choose anything that you want as long as it's not touching the line. So once again, we could use the origin, and we're going to plug it into the original inequality and see if it gives us a true statement. So we have 4 times 0 plus 3 times 0. We have greater than or equal to 12. We want to see if this is true. So simplify a little bit. 4 times 0 gives us 0, plus 3 times 0 gives us 0 as well. So we have 0 is greater than or equal to 12. And now 0, this is not greater than or equal to 12. This is not a true statement. Now, since our test point was on this side of the line, and when we plugged it in, it gave us a statement that's not true, that means we have to shade in the other side. So I have to shade this side of the line. And now I have the graph for the inequality. Okay. So let's take a look at one more, and then we'll go to another objective. Okay, so graph inequality, this time we have 2x minus 7y is greater than 0. Okay, so first change the inequality to an equal sign. And now let's get this into slope-intercept form. So I'm going to go ahead and subtract 2x from both sides. I get negative 7y is equal to negative 2x. And now go ahead and divide by negative 7. So I get y is equal to 2/7 x. And now I can use my slope and y-intercept to graph. So my slope here is 2/7. And my y-intercept, so if we don't have a plus or minus some number here, it's really like a plus 0. So our y-intercept here is 0, 0. Now let's go ahead and graph it. So we have our y-intercept, which is 0, 0. And now my slope is telling me to go up 2 to the right 7, which gives me this point. Now, since the inequality I have is just a greater than symbol, it's not greater than or equal to, this means I'm going to have a dotted line. So let's go ahead and connect these with the dotted line. And now I have the graph of that line. But remember, we still have to figure out what side to shade in. So let's go ahead and pick a test point. Now, what makes this problem a little bit different from the other ones? Remember, our test point cannot touch the line. So in this case, I cannot use the origin as a test point. So what I'm going to do is use just some other point. Let's go ahead and use something else that has a 0. How about this point right here? 0, 1. Okay, I know for sure that's not touching the line. So we're going to pick 0, 1, and we're plugging it into the original inequality, which was 2x minus 7y greater than 0. And let's see if this gives us a true statement. So I have 2 times 0 minus 7 times 1. I want to see if this is greater than 0. So 2 times 0 gives me 0. Negative 7 times 1 gives me negative 7. I have greater than 0. Now negative 7 is not greater than 0, so that's not a true statement. So since my test point was on the top part of that line, this is where my test point was right here, and it gave me a statement that's not true, I have to shade in the other side right over here. And now we have our graph. Okay, so we have a couple more problems. Our next objective, we're going to be solving systems of linear inequalities. Now with this objective, we're essentially doing the same thing that we just did, but we have to do it twice, or maybe 3 times. Okay? So we have to do it for each inequality that we have. And then to get our solution, we have to see what side they have like in common. What shaded part do they both have in common? And that'll be our solution to the system of inequalities. So I'm going to label this first one as my red graph. I'll label the second one as my blue graph. Okay. So first, let's go ahead and change our inequality to an equal sign. So we have y is equal to x. And now in this case, our equation is already in slope-intercept form. My slope here is, remember the number in front of our x, which is 1. And then my y-intercept here is 0, 0. So let's go ahead and graph that. So I have 0, 0 is my y-intercept, and my slope is telling me to go up 1 and then to the right 1. Okay, I have 2 points, and now I could go ahead and sketch the graph. So since it's just a less than symbol, that means I have a dotted line. Okay. And now let's go ahead and pick a test point to see what side we're going to shade in. Remember, you could choose anything as long as it's not touching the line. I'm going to go ahead and choose the point 0, 1, and we have to plug it into y is less than x. We have to see if it gives us a true statement. Okay, so I have my y value, which is 1, and I have less than my x, which is 0. Now 1 is not less than 0, so this is not a true statement. Now instead of actually shading this whole side in, what I'm going to do is I'm going to put arrows indicating this is the side that I shaded in. Okay. Otherwise, it kind of gets a little bit messy if you just start shading everything. Okay, so let's put these arrows indicating we shaded on the right hand side. Okay. Now let's take a look at our other equation. And we'll do the same thing. So first, okay, let's go ahead and change the inequality to an equal sign. So we have y is equal to negative x plus 3. And now luckily, this equation is already in slope-intercept form as well. So we have m is equal to negative 1. And our y-intercept is 0, 3. Okay. Now let's go ahead and graph it. So I have 0, 3, which is this point over here. And now my slope is telling me go down 1 and then to the right 1. Now in this case, since our inequality was greater than or equal to, that means I'm going to have a solid line. Okay. And now let's go ahead and pick a test point to see what side to shade in. So we have a test point. Okay, now in this case, since the origin is not on that blue line, I could go ahead and use 0, 0 for my test point. And then I'm going to plug it into our original inequality, which was y is greater than or equal to negative x plus 3. And then we'll see if this gives us a true statement. Okay, so we have 0 is greater than or equal to, okay, negative, and then my x, which is also 0, and I have plus 3. Now let's go ahead and simplify. I get 0. I get 0 is greater than or equal to 3. Okay, well, 0 is not greater than or equal to 3. This is not a true statement. So now we have to shade in the other side of the test point. So the other side of the test point would be this side over here. Now you have to determine what part do both of these inequalities have shaded. That's the part that we're going to have completely shaded. Okay. So if you take a look at this side over here, this isn't covered by any of the inequalities. So it can't be that side, can't be that part. This section over here is only covered by the blue graph. This is only covered by our second inequality. But now if we take a look at this part over here, this is covered with our first inequality and our second inequality. So this is the section that we're going to shade in. This would be the solution to the system of inequalities that was given to us. Any point that's in that green section makes both of those inequalities a true statement. Now let's go ahead and take a look at one more problem. Okay, this time we have 3 inequalities. Okay. I'll put the first one as my black graph. So let's go ahead and change the inequality into an equal sign. So we have x minus y is equal to 2. Let's go ahead and subtract 2 from both sides. We get negative y is equal to, I'm sorry, not 2. My mistake. We're going to subtract x from both sides. Okay, so we get negative y is equal to negative x plus 2. Last step to get y by itself, let's go ahead and divide both sides by negative 1. We get y is equal to positive x minus 2. So my slope here is 1, and my y-intercept is 0, negative 2. Okay, so let's start with our y-intercept, and then use the slope to find one more point. So we're going to go up 1 to the right 1. We get this point. Now since it's less than or equal to, this is going to be a solid line. Okay. Now let's go ahead and pick a test point to determine what side we're going to shade in. So 0, 0 is not on that line, so we could go ahead and choose that as our test point. And we're going to plug it into the original inequality. Okay, so we have 0 minus 0 is less than or equal to 2. So we get 0 is less than or equal to 2, which is a true statement. So that means we're going to shade in the same side as the test point. So we're going to shade in the top part of that line. Okay, so I just put arrows indicating that's the side I'm shading in. Okay, let's take a look at our second inequality. So we have x, so let's first change it into an equal sign. So we have x plus 2y is equal to 8. Okay, let's get y by itself. So subtract x from both sides. We get 2y is equal to negative x plus 8. Now divide both sides by 2. We get y is equal to negative 1/2 x plus 4. So my slope here is negative 1/2. And my y-intercept is 0, 4. Okay, so let's use this information and graph our line. We have 0, 4. And then my slope was negative 1/2, so it's telling me to go down 1 to the right 2. I get this point. And now our original inequality was just greater than. So that indicates we have a dotted line. Okay. And now let's go ahead and choose a test point. So we could choose the origin again because it's not touching that line. So our test point, let's go ahead and use 0, 0 and plug it into the original problem. So we have x plus 2y. So x plus 2y was greater than 8. Okay, let's go ahead and plug it in. So I have 0 plus 2 times 0 is greater than 8. Go ahead and simplify. The 2 times 0 just gives me 0. 0 plus 0 gives me 0. So I have 0 is greater than 8, which is not true. So since this statement's not true, I have to shade in the other side of the test point, which would be the top part of this line. And now we have one more inequality here. We have this last one where it's y is less than or equal to 4. So let's go ahead and change it to an equal sign first. Let me just separate all these. Okay, so I have y is equal to 4. Now y equals 4. Okay, we don't have any x's in this equation, which is telling us that we have a horizontal line. So you're going to go to where y is equal to 4, and you're going to draw a line going through that point. You're going to draw a horizontal line. So since we have the less than or equal to symbol, this is going to be a solid line. And now when you have a vertical or horizontal line, it's not really that necessary to choose a test point because our inequality is telling us that y has to be less than or equal to 4. Well, less than or equal to 4 is everything below this line. And now we're going to go ahead and determine, okay, what section they all have in common. Okay, so if you take a look at this section over here, this is only covered by the third inequality and the first inequality. It's not covered by the second inequality. So it can't be this section. This section over here is only covered by the first inequality. This section over here, this is only covered by the first inequality and the second inequality. So it can't be that section. This small section over here is only covered by the second inequality and the third inequality. But if you take a look at that part in the middle, this little triangle, this is covered by all of the inequalities. It's covered by the first one, it's covered by the second one, and it's even covered by the third one. So that little green section, that's going to be the solution to our system of inequalities. This is the part where, this is the section where they all have in common. So any ordered pair that's in this section will make all three of those a true statement. So that was it for section 3.7. As always, if you have any questions, just let me know, email me, and I'll get back to you.